Hello children, welcome to the physics class. I think from the slide you'll be knowing what we're going to talk about today. Yes, current electricity. Just imagine we're going to live in a world without electricity, that is without light or any electrical appliances. Suppose say we have a current failure, we will all start to grumble and we'll be just waiting when we will get electricity. So it has been a very important, or electricity plays a very important role in our life. Just imagine the world with light. Then we get a ray of hope when the light comes. Yes, we already know that electric current is produced by batteries. It is not only produced in batteries. In nature, electric current is prevailing in the form of lightning and thunder. Lightning bolt produces enormous electric current in a short time. During lightning, very high potential difference is created between the cloud and the ground. So charges flow between the clouds and the ground. So current electricity is a study of flow of electric charges. Now, it owes its origin to Alexandra Volta, who produced the first battery, or who invented the battery, which produced the first steady flow of electric current. Now, in the modern world, we use many appliances using electricity. For example, all the communication system, home appliances, and electronic devices work under electricity. Now we will see what is electric current, what is resistance, and the other related formulas in your electricity. What is electric current? Now you know matter is made up of atoms. Each atom consists of positively charged particles as well as negatively charged particles. That is, you have the nucleus, which is going to be positively charged, and the electrons revolve around the nucleus. This we have already discussed. Now, atoms and metals have one or more free electrons which are loosely bound in the nucleus. These are called as free electrons. Okay. Now, conductors are substances which have an abundance of free electrons which keep them moving. But we cannot say conductors can conduct electricity, because for electricity to occur, or for electric flow to occur, it should have a potential difference. That means one point should be at a higher potential and the other point should be at a lower potential. For example, say you're watering the plants. Now you have to hold the hose pipe a little higher, then only you will be able to get the full flow of water. That means, suppose say two persons are holding a pipe. If they're going to have it in the same level, then there will be no flow of water. But if one is holding a little higher and the other one is holding a little lower, then there will be a flow of water. In a similar way, electric current also, in order to flow, it should be maintained at different potential difference. That is, one should be at a higher potential and the other should be at a lower potentials. So in general, you cannot say conductors can conduct electricity. If the conductors are maintained at a potential difference by means of a battery, then free electrons will be drifted to the positive terminal and hence there will be a flow of current. Now, how do you define electric current? It is defined as the rate of flow of charges through a given cross-sectional area, or it is represented as I, which is equal to dq by dt. That is the differential quantity. You call it as dq by dt. And the SI unit of current is ampere. And 1 ampere is equal to 1 coulomb by 1 second. I hope you know the unit for charge is coulomb and the unit for time is second. So I write 1 ampere is equal to 1 coulomb by 1 second. Now, 1 ampere of current is equivalent to 1 coulomb of charge passing through a perpendicular cross section in 1 second. And electric current is a scalar quantity. Next, we will see how the current flows by conventional method. Now, usually we say the flow of current starts from the positive terminal and ends at the negative terminal. As you see in the diagram, you have the flow of conventional current from the positive terminal to the negative terminal. AB is a conductor. Okay. So you have the battery which indicates the positive and the negative terminal. So the flow of current, conventional current, is from the positive terminal to the negative terminal. But actually, what happens inside is it is only due to the flow of electrons. That is how you have your arrowheads in red, which shows you the electrons are drifted to the positive terminal, and that is how you get a flow of current. So the flow of current in a circuit is from the positive terminal to the negative terminal of the battery. This is known as conventional current. But the flow of current constitutes the flow of electrons constitutes the flow of current. Okay. So the electrons, movement of the free electrons, will constitute the flow of current. Next, we are going to talk about drift velocity. Now, say if you have a free electron, or the electrons which are going to be maintained in an electric field, they have a zigzag path. They will not have a continuous path. They will have a zigzag path. So drift velocity is drift, as the name implies, and the electrons are going to be drifted from the negative terminal to the positive terminal. Drifted means driven from the negative terminal to the positive terminal with a velocity which is known as the drift velocity. So it is the average velocity acquired by the electrons inside the conductor when it is subjected to an electric field. It is denoted as Vd. Now in this you have a sentence known as mean free path. The average time between successive collisions. Now when the electrons are moving inside the conductor, they undergo collisions. Okay. Now the average time between successive collision is represented as tau. Now we will see how you get the value of your drift velocity. So the acceleration A experienced by the electron, acceleration is nothing but we get from the equation F is equal to m into A. You know, F is equal to m into A, or A will be equal to F by m. Now in this case it is the electrical force. So F is equal to minus E vector. Minus denotes it is an electron. Therefore substituting the value of F, you get A vector is equal to minus E vector by m. Now drift velocity. Velocity is nothing but, as you go from your scratch, you have acceleration is nothing but rate of change of velocity. So velocity is nothing but acceleration into time. Tau is nothing but the mean free path, that is the successive time taken for successive collision. So I am representing Vd is equal to A vector into tau. Now you know A will be equal to minus E tau E vector by m. Now this quantity, that is minus E vector by m, is taken as mu into E vector, where mu is known as the mobility of the electron. It is defined as the magnitude of the drift velocity per unit electric field. That is, mu is equal to Vd by E vector. And the SI unit of mobility is meter squared by volt second. Okay, that is the SI unit of mobility. You can expect this in 1 mark question. The next one, the misconception that is going on. Now we know battery. Battery is not a source of electrons. It just sets the potential difference so that the wire connected in the closed circuit will make the electrons flow. Okay, suppose say you have a battery, it just maintains the potential difference from the positive terminal to the negative terminal such that the wire which is connected will have a flow of electricity. And that energy is used by our electric bulbs, fans, etc., which run on electricity. this is the last slide. So Thomas Alva Edison said, "We will make electricity so cheap that only the rich will burn candles." Okay, with this I end today's session. Thank you.